Hey everyone, welcome back for another deep dive. Today we're looking into something that's, well, frankly, pretty terrifying.
Yeah, you could say that.
It's about a newly discovered asteroid called 2024 YR4.
Right. And it has a chance of hitting Earth,
A chance of hitting Earth in 2032.
which is, not that far away.
Yeah, not that far away at all. It's about the size of the Statue of Liberty.
Big, yeah.
And, well, this thing has the potential to be a real city killer. So that's what we're going to look into today. What do we know? What's being done to figure out how much of a threat this thing really is?
Well, I think what makes YR4 so interesting is the uncertainty around it. It was first spotted late last year, December 2024,
Right.
and it immediately shot to the top of NASA's watch list.
Of course.
But estimating the size of an asteroid, from Earth is tough. It's really challenging. And that's why NASA is turning to the James Webb Space Telescope to try to get a clearer picture.
Right. Now, I've heard about these challenges before with, just trying to observe these things. Isn't it because Earth's atmosphere can really distort, our observations?
Oh, yeah. It's a huge problem.
And a bright asteroid, when we look at it, doesn't necessarily mean that it's a large asteroid, right?
Yeah, exactly. It's like, how do I put this? It's like trying to measure a grain of sand from across a crowded room.
Okay.
The atmosphere blurs the details and light can be very deceiving.
Okay.
But the James Webb Space Telescope is out there. It's 1,000,000 miles from Earth, and it bypasses those limitations.
Okay.
And it also has these incredibly sensitive infrared instruments on it.
Infrared. Now, doesn't that have something to do with heat?
Yeah, you got it. Everything in the universe, emits some level of infrared radiation or heat.
Okay.
And by measuring that heat signature, the James Webb Telescope can give us a much more accurate estimate of YR4's size.
Okay, so getting that more precise measurement is key here. But why is knowing the size of this thing, of YR4, so crucial?
Well, size matters when it comes to asteroids. A small difference in diameter can make a huge difference in terms of impact.
So we're not just talking about a few broken windows here.
No. We could be talking about an event like the Tunguska event back in 1908,
Right.
where an asteroid, believed to be about the same size as YR4, flattened, hundreds of square miles of Siberian forests.
Hundreds.
Yeah.
Well, square miles. Imagine that kind of energy
Yeah.
unleashed on a city.
Yeah.
The devastation would be immense.
Wow. That's a sobering thought.
Yeah.
So knowing the size of YR4 is really the first step in figuring out if we need to, take action.
Right.
And the James Webb Telescope is set to observe this thing at its brightest in March 2025.
That's right, yeah.
Yeah.
And again, as it moves away from the sun, so we get 2 chances to get the data we need.
These observations are going to be crucial for, planetary defense organizations like NASA and the European Space Agency, the ESA, to decide what to do.
So we're kind of in a race against time here.
Yeah, very much so.
Because if this thing really is on a collision course,
Yeah.
we need to know sooner rather than later.
We do.
But what are our options here? What could we even do to, stop an asteroid?
Well, there are a few things that, scientists are exploring.
Okay.
One is a kinetic impactor,
Okay.
which is basically just a high-speed spacecraft that would ram into the asteroid and try to, slightly alter its trajectory.
Okay.
Another is a gravity tractor,
Okay.
which uses a spacecraft's gravitational pull to kind of nudge the asteroid off course. But, this takes time.
Right.
It has to be done over time.
So it's kind of like a cosmic game of billiards, but with, incredibly high stakes.
Yeah, that's one way to put it.
But these options, they sound incredibly complex.
They are very complex, and each one comes with its own set of, technical challenges and, of course, costs.
Right.
But the more we know about YR4, the better we can, assess what might be the most effective.
And we only have until 2028 before this thing disappears from view.
Yeah, that's the other thing.
For several
So it
years.
disappears for quite a while.
They being much harder to track.
Very much so.
And then, potentially even act on.
Yeah, that's right. So every piece of information we can gather between now and then is critical. Even with the current estimate, if YR4 were to hit us, we're talking about an energy release equivalent to 15 megatons of TNT.
Okay. For context.
Yeah, that's over 100 times more powerful than the bomb that was dropped on Hiroshima.
Wow.
Yeah.
This deep dive has really highlighted, the just incredible power of these objects.
It is amazing, yeah.
And the importance of staying vigilant.
Yeah. We've come a long way in our understanding of asteroids and planetary defense. But YR4 is a good reminder that there's still so much we don't know and, so much more to learn.
Absolutely. So we're left with a lot to think about here.
Yeah.
What other advancements in technology do we need to really safeguard our planet from these kinds of threats? This has been quite a deep dive.
It has.
It's given us a lot to ponder, that's for sure.
It really has.